Okay, for Algebra 4.3 notes, it is talking about patterns and nonlinear functions. So let's go ahead and discuss what a nonlinear function is. So for the definition, a nonlinear function, it is a function, but whose line is not, that's why not going to be a straight line. Linear is a straight line, nonlinear is not. So it is a function whose graph, so if you were to graph it, whose graph is not a straight line. Okay, or part of a line. It can't even be it can't be a line or any part of a line. Okay, so what type of a function would not be a straight line? Well, let's look down here at these examples. These are linear. Look, straight line. The dots end up going straight in a straight line. They don't have to be connected to be a function, a linear function. You can just tell that it's a straight line. Here is another straight line. These are all linear. The prefix to linear, the first four letters spell out the word line. These are all straight lines. So when we go to non-linear, they would be functions that are curves, functions that are curved, functions that are straight lines, but they're two parts, so it's broken up. It's not a continuous straight line. So these are all still functions, but they are not linear. They're non-linear. Okay, so for the first two, we're going to look at them and classify them as linear or nonlinear. So you've got a pizza, radius and area. So let's check to make sure that these are increasing at a constant rate, because if they're increasing at a constant rate, that will be what makes it in that straight constant line. So from 2 to 4, you're adding 2. From 4 to 6, you're adding 2. From 6 to 8, you're adding 2. From 8 to 10, you're adding 2. This is looking like it's going to be linear. Let's start adding over here. 12.57, I have no idea what that is. So I'm going to have to subtract. So it looks like I want to subtract 50.27 minus 12.57. That is 37.7. So it's adding 37.7. Okay, let's keep going. Oh, I can tell that's already going to not be 37.7. But just to double check, 113.10 minus 50.27, 62.83. This increased 62.83. So I'm actually going to stop right there. This looked like it was going to be constant, but then we come over here and it's definitely not constant. So if this is a function, which I'm sure it is, this is going to be a not linear function, so non-linear. Okay, let's check out the cost of the sauce. So from 2 to 4, we're adding 2. From 4 to 6, we're adding 2. From 6 to 8, we're adding 2. From 8 to 10, we're adding 2. Looking good. From 80 cents to $1.60, you're adding 80 cents. From $1.60 to $2.40, you're adding 80 cents. From $2.40 to $3.20, you're adding 80 cents. And from $3.20 to $4, you're definitely adding 80 cents. So these are a linear relationship. The pattern is constant, which will make it linear. So down below, they've actually graphed this for us. So they took our numbers up here and they've shown us where the dots would be. So I can see that it does have a relationship. It's just not a linear relationship. So this is a curved or nonlinear function. Oh, it tells it right here. The graph is a curve, not a line. So it is nonlinear. All right, and then with the pizza sauce cost, they actually took the table and turned it into a graph. And as you can see, each dot connects in a straight line, which makes it linear. Okay, let's turn it over to the back. And we'll check the did you know how on your own part. Okay, so it first says graph the function. I'm so sorry I did not give you a graph to do this, but let's just draw a quick graph. 0, 1, 2, 3, 4 is the x or the inputs on the x-axis, so 0, 1, 2, 3, 4. And then the y-axis goes from 12 to 16. So we'll just say this is 10, 20. There'd be a 5 in between. There'd be a 15 in between. Okay. At 0, put a dot at 12. So 0, 12 is your first ordered pair. So 0, 12. It's going to roughly be about right there. 1, 13, 1, 13. 2, 14. 3, 15. 4, 16. Okay, my dots are not perfect. However, what I can see is that it is going to be linear. So we could also tell because each of these are only increasing by 1, and each of these is also increasing by 1, which is constant. So that makes this linear. All right, number 2, the ordered pairs, all of these represent a function. What is the rule? Okay, the rule would be like, what are we doing to each input to get each output? So it looks almost like we can subtract 2. So 0 minus 2. 1 minus 2, though, is not 1. So my idea of subtracting 2 is not going to work on all of these. So I'm going to show you really quickly a much better way to come up with a rule. So I'm going to take these ordered pairs and I'm going to turn them into a table. Just find a space off to the side. Actually, I'll do this down below. So make a quick table of x and y values, and I'm going to write out each of these. So 0, negative 2, 1, 1, 2, 4, 3, 7, and 4, 10. Okay, I hope you guys really catch on to how I'm doing this, because this is going to help the whole year if you figure out how to do this. So in order to figure out how to get from here to here, if it's not just automatically clicking, like if you're not like, well, I can't subtract 2 because that doesn't work, so maybe I add 4. Well, that works here, but that doesn't work here. And if it's just not clicking, if you're not just getting it on your own, here's an easy way to do it. Find out what the y's are doing. There will be a pattern. Find out what the y's are doing. The y's are doing plus 3. From 1 to 4 is plus 3. From 4 to 7 is plus 3. From 7 to 10 is plus 3. And if these are counting up by 1s, which they are, 3 over 1 would just be 3. That is the number that gets multiplied by your x. Okay, so we're taking x and we're multiplying by 3 because our pattern is plus 3. So it's 3x. And then it's going to be plus or minus something. We're not done with the rule. If it was just 3x, that would be 0, that would be 3, that would be 6, 9, 12, but it's not. It's 3, and then it's adding or subtracting something. So 3 times 1 is 3. To get it to 1, you subtract 2. So let's just see if it's minus 2. We don't know for sure yet. 3 times 3 minus 2 is 7. 3 times 4 is 12. Minus 2 is 10. So this is it. Now I'm going to show you a shortcut. I showed you how to get the 3. The 3 was see what the y's are changing by. And by the way, that only works when the x's are changing by 1. So we'll get into more of these later that are changing by other things. But if it's 3 over 1, then 3 over 1 is the same thing as 3. And that's how to get this number. And then to get your plus or minus, go to when x is 0. When x is 0, whatever y is what comes after this. Okay? So if this is not ringing a bell, if you have no idea how to get from here to here to here to here to here to here, find out what your y's are changing by and make it a fraction over what your x's are changing by. In this case, 3 over 1 is just 3. And then go to when x is 0, and that is what else you add to your rule. So 3x minus 2 works every time. So the rule is multiply by 3 and add, or sorry, not add, is it subtract? Subtract 2. We'll do a few more of these, but it's good for you to understand that early on. If you get that, this will work every time. Okay, number 3, what rule could be represented? Well, let's see if we can take all of our x's and square them to get our y. So x squared, so 0 squared is 0, that works. 1 squared is 1, and they have it as -1. So this won't work. Let's try to take it and cube it. So I can already tell you that's not going to work, because even forget the negative, just pretend the negative's not even there. This isn't going to work because 3 times 3 times 3 is 27. So anything to the third power is going to be bigger than the numbers they have down here. So let's check and see if -x squared works. So what you're going to do is you're going to square it and then make it negative. The negative's kind of going to attach itself back to it. So 1 squared is 1, and then we're going to make it -1. 2 squared is 4, and then we're going to make it -4. 3 squared is 9, -9. 4 squared is 16, -16. So it is this one. All right, the last few are super easy. We're just asking linear or nonlinear. Obviously, that's a straight line, so it is linear. That is not a straight line, so it is nonlinear. All right, and then the very last one, a classmate says that a function in, okay, so this function table is the rule x plus 1. So they're taking each of these x's and adding 1 to get y. That works. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is not 5. 3 plus 1 is not 10. 4. So it doesn't work for all of them. So that's not right. Describe and correct your classmate's error. So let's try my little trick over here. See if you guys can start to figure this out. So each of these is increasing by 1, so we're good. Each of these, that's 1. Ooh, it won't work. That's 3. That's 5. Remember, the only time this works is if you have a constant pattern, because that makes it linear. This looks like if it's increasing by different amounts each time, it is going to be non-linear. So non-linear, a curve, is going to be something like this, something that's squared. These are not linear. These are subtracting 1, subtracting 3, subtracting 5, subtracting 7. So I bet this is also going to be something squared. Let's see if this works. So x squared plus 1. So 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. 3 squared is 9, plus 1 is 10. And 4 squared, 4 times 4 is 16, plus 1 is 17. So this is what my classmate forgot to do. Since this is not linear, it's going to be something like squared or cubed or something else. It's going to be nonlinear. So it should have been y equals x squared plus 1.